How's it going, everyone? Welcome to the sixth drill for the spring 21 semester. Today we're going to be talking about mediation. It should be a pretty quick drill. There's not a whole lot of new stuff on the R side of things, so it shouldn't take too long to get through this. You will need to install the mediation package if you don't have it already. You can just undo that comment and run that line, or highlight and run it. I've already run the tidyverse and mediation libraries, so I'm not going to run those again. But you'll notice that I have some plots that I've already made, as I've done before. And these plots are not in the code, so if you're wondering why I have these plots, I ran it on a separate script before I got started. So don't think that you're missing something or something's not running right because you don't have plots showing. So today we're going to work with the Prestige data set, which comes from the car library, or the car data library that loads when you load car. So if we look at what this is the 1971 Canadian census. It looks at the occupations based on the Canadian census. It has 102 different jobs and 6 variables. One is the average education of somebody in that job role. One is the average income of that job role, the percentage of women in that role. One is a measure of prestige based on a survey done a few years before where people just rated the prestige of various jobs. That's the perceived prestige of these different job things. Then there's an occupational code, which is just like a numeric identifier of a specific job, and then type being blue collar, white collar, or professional. So if we run this, pull this data, we're going to save it as in our environment as prestige, and then we take a glimpse. We can see those 6 variables across 102 different jobs. So later on, we'll be using education and prestige as our predictor and mediator. So I'm going to go ahead and center those just to make interpretations easier. Now, recall that when we're talking about mediation, the generic terms that we use are X, M, and Y. And so there's some effect of X on some outcome Y. But when we're looking at mediation, what we're trying to find out is perhaps there's not it's not that X directly affects Y, but rather X influences some other mediator M, and that mediator is what actually then changes and changes that or has the effect on Y. So, for instance, we could say, what about the number of years of education leading to higher incomes, but is that mediated by prestige? So in other words, is this relationship between education and income? It's not that the more education you have, the higher paying your job is just, outright, but rather the more educated you are, that leads to getting more prestigious jobs, which then in turn, those more prestigious jobs are lead to higher incomes. So in other words, it's not just the number of years of education. You can still have a high education and low income if you don't land a prestigious job, but having a higher income means you're more likely to have a prestigious job, which will influence your income down here. So when we look at the steps of assessing mediation, first you have to make sure, is there an effect to mediate? Is there an effect, direct or indirect? Is there an effect of education on income? Because if you go to step 1 and there's not an effect of education on income, then there's no effect to mediate. So what sense does it make to then try to mediate an effect that doesn't exist? So then you have to test the relationship between your predictor and your mediator. So here we want to say first, okay, can we predict someone's income, or how well can we predict someone's income based on their education? And then we say, now, what is the relationship? Can we predict the prestige based on someone's education? And then the third step is to test the relationship between prestige and income controlling for education. So in other words, looking at this B path while controlling for this C path here. And then finally, we will use bootstrapping to test that indirect effect. So in our education C will be our X, income is our Y, and prestige C is our M. So we're going to start just by fitting these simple models. So first, again, step one, test the relationship. We want to know what is income regressed on education. What is, can we predict income based on education right here? And so we run, our model step one, and we see that yes, education does significantly predict. Yes, education does significantly predict income here. And on average, somebody with the average amount of education is expected to make about $6,800 per year. And then that is expected to go up by about $900 for every additional year beyond average of education that one has. So there is an effect of education on income. But like we said, perhaps it's not that education directly, like the more educated you are, the more you get paid, and that's not really what it is. So on our step two, we are going to regress prestige on education to see, can we predict the prestige that somebody the prestige of the job that somebody gets, rather, based on how many years of education that they have. And when we look at our summary, we can see that yes, that is a significant relationship, and this is it's basically zero, because remember, these are both mean-centered, and so the estimate for of zero means the average, and so this here, where it has this E minus 15, that's almost zero, and the only reason that it's not zero, and the reason that it's having this crazy scientific notation, is actually just because of like rounding errors in the computations when you take means and things, and so this is actually just zero is the intercept, and then our slope of education is 5.361. Finally, our third step will be the relationship between that mediator and the outcome controlling for the other. So in other words, we want to see what's the relationship between prestige and income controlling for education. And so once we do that at step three, which is simply fitting a model with regressing income on both education and prestige. And so now we can see that controlling for the average education is actually no longer a significant predictor here, but prestige is. So the way that this would be kind of the end of the line for what used to be done for mediation. That they'd say, well, here, now we can see that prestige mediates the effect between education and income, because education significantly predicts income and education significantly predicts prestige. But once you prestige and prestige significantly predicts income, but education no longer significantly predicts income once you include prestige. So what's happening here is, as people's education goes up, their prestige of their job goes up, and that's the reason that their income goes up, not necessarily just because they had extra years of education. It doesn't matter if you have a PhD if you don't have a prestigious job. You may not be making as much money. But luckily, with the technology that we have available to us these days, we can be a little more rigorous than this, and we're going to conduct bootstrapping with the mediation library and a function called mediate. Now, what mediate takes is you put in model A, which is like your step 2 model. Model B is your step 3 model. Treat equals something, and that's the treatment, the predictor. And mediator equals blank, and you put in your mediator, and then boot equals T. You can also adjust how many simulations it does. By default, it does 1,000 iterations of a bootstrap. So what does it mean? What do we mean when we say that this is bootstrapping our mediation model? Well, the problem with what we have here is that it's these effects may be limited specifically to this sample. It could just be an artifact of the sample that we have. What bootstrapping will do is, if you imagine sampling from within our data set. So we have 102 jobs, and it pulls one of those out and puts it in a new data frame, and then puts it back into this one. And then it randomly selects another of these 102 and puts it in a new data frame. And then it selects a third randomly of this, and it just resamples from our sample. So in other words, from this thing of 102 observations, we draw 102 new observations by randomly selecting, and sometimes the same observation might end up in our bootstrapped sample twice, and we end up with things that don't end up in our sample. But so conceptually, that's kind of what we're doing. Is if you randomly draw a new sample from within our sample here and conduct the analysis, and then do that again and again and again and again. And so you do that 1,000 times. Imagine 1,000 times resampling from within this data and then looking across all of them. And if it was just an artifact, if the effects that we found here are just artifacts, a random chance, then it's highly, highly unlikely that once we sample from this and do this 1,000 more times, that we're going to consistently keep getting this effect. So that's kind of one way that you can think about what we're doing by bootstrapping is basically, in a sense, resampling from our own data to see if we lose our effects, when just a couple people end up getting removed. So again, we have our mediate function. This is from the mediation package. And we put in our mod step 2, mod step 3, our treat equals education.c, that predictor. Mediator equals prestige.c, which is that mediator, and boot equals t. And once we run this, now this may take some time on your computer. You'll see the stop sign running right here. So even though it looks like it's not doing anything, it is computing as long as that stop sign is running. And patience is just a virtue, and sometimes things take a little bit longer. Depends on your computer, depends on the size of your data and how complicated your stuff is, but that's possible. I added this note here that if you get errors, make sure there are other libraries. For instance, the PSYC library has a mediate function. And so if you get errors when you try to run this and it doesn't run the way that you're expecting it to, make sure that you don't have any other libraries loaded that also have mediate functions, or just try explicitly calling this from the mediation by putting in that explicit call with mediation : mediate. That way R knows which mediate you're talking about. Anyway, so we have finished now running our bootstrapping. That stop sign has gone away. So we can look at the summary of this object that we created. And when we do that, it tells us we did 1,000 simulations with 102 random samples. And what we find here, the ACME, this first line, is the average causal mediation effect, or what is commonly called the indirect effect. ADE is the average direct effect. And total effect is exactly what it sounds like. And then proportion via mediation is how much of the effect was mediated. So we talked about the idea of there being this thing called total mediation or complete mediation or partial mediation. And so when you're looking at these things, I'll go ahead and switch to this next plot. Here's what this path diagram would look like for these models. So what this tells you, the direct effect, this 169.63, that is that direct effect of education on income. It's what's, you can think of that as the actual effect of the total effect once you take out that indirect effect through prestige. What that means is that based on one's education, we can predict what their prestige score is going to be. Based on their prestige score, we can predict what their income is going to be. So when we combine those two things multiplicatively, we get that indirect effect of education on income. But the actual total effect is very little. If we just throw this med object that we made into a plot, and then main equals 1,000 bootstrap is just setting a title, and then xlim negative 752,000 is just setting an x-axis limitations. So this is what our bootstrapping sample, or our bootstrapping results looked like. Again, here is our indirect effect. Here's our direct effect. Notice how the confidence interval of that direct effect captures 0, which is what we want here. This is called total mediation or complete mediation. If that direct effect did not capture 0, perhaps maybe it was shifted over here and it stopped down here. Even if our indirect effect is bigger, and after we put in that mediator, the effect of that predictor goes down some, even if it's not, it becomes a 0 or statistically 0 relationship, that would be what we would refer to as partial mediation. So this is a good thing. We want this ADE, this direct effect, we want it to be 0 because we don't want a direct effect, but we do want to see indirect effects. And so here, just looking at if it makes a difference if we run more simulations, it would help if I have in the right variables. So we'll let this run for a minute. And once it gets done running, so this is running 5,000 simulations now. Instead, exact same thing we did last time. Only this time we're running 5,000 simulations instead of just 1,000, which is also why it's taking us longer here. So now we can see if we can toggle back and forth between these two plots, and it's almost hard to tell outside of the plot changing, but you can see if you look real close at the very ends, you can see that the confidence intervals shift a little bit. They get a little bit tighter down here with 5,000 bootstraps, or maybe they expand out rather. But anyway, so they're pretty stable, and when we look at these, they're also going to be more or less the same thing. There could be a little bit of differences there, but that's just the randomness of bootstrapping. Point is that like 1,000 bootstrapping simulations is adequate. Like you don't need to really feel like you need to do any more than that. Finally, we all of these variables are measured and not manipulated. So there might be other possibilities for mediation. For instance, we could ask if more years of education leads to careers with higher prestige mediated by the income. So this is asking if, in other words, as people have higher education, they get higher paying jobs, and those higher paying jobs are then in turn seen as more prestigious. And it's not just that these jobs are seen as prestigious because of the amount of education that it took to get that job. And so here, this is doing the same thing as we did before, only note that this time I'm not bothering with using the centered variables because I'm not worried about interpreting it. We're just looking at how this works. And we're going to run these same three models. So first, you regress your outcome on your predictor, and so that you can test your to make sure that there is an effect to mediate. So we will regress prestige on education. Then we want to test the relationship between income and education, regressing income on education. And then we want to test the relationship between income and prestige controlling for education with mod 2 step 3. And so in our first step, we see that, yes, there is a significant relationship. We can predict how prestige based on someone's education. And unsurprisingly, that's a positive relationship. The higher their education, the higher their prestige ends up being. In our second one, we can see that, yes, education predicts income. And unsurprisingly, it's a positive relationship. The higher education you have, the more income they end up having. And then when we look at step 3, we see that now the relationship between education or income and prestige is significant, as is the relationship between education. It is still significant. And when we look at that at our effects, we can see that no, we did not. There's no mediation here based on this particular model, but we can't rule out that this is actually the correct model. We can't just say, just because we like this model better, and oh, well, this one must be the right one because when we ran this model, there was no mediation. That's the problem with only having measured variables and no manipulated variables. And so there are ways that we could see empirically whether this first model that we ran or like this new flipped around model is the reality, but we can't here because of the nature. So just be aware as you do these sorts of models that you, just because something fits, like this model, that doesn't necessarily mean that you can know for sure that it's right. There still needs to be empirical manipulations of things to be able to conclude causal relationships here. Short of that, there are technically some ways of getting into causality without empirical manipulations, but that's a whole other topic that I am not going to be getting into. That said, this week, like I said, it'd be quick. 'Cause really, the only thing that we're doing is using this mediate function, putting in 2 of our models, a couple specific names for variables, and then check your summary to get your indirect effect, direct effect, total effect, and the proportion of that effect that was mediated. And then you can throw it into plot if you want to see, some plots just real quick like that. And that's about it. If you have any questions, let me know, and I will talk to y'all later.